Good day all. Welcome to Python Coding Lesson 7. In today's lesson, we will be focusing on functions, and this will be the first part of functions. Right, so before we can actually go on to that lesson, let's have a quick recap of what we did yesterday. On yesterday's lesson, we went through the while loop, and in the while loop that we learned, it will repeat as long as our condition is true. And the syntax for the while loop was initialize. That means the variable that we are testing in the while loop. So we have to make sure that it's created before it. So we test the variable that we created. And if that variable that we created condition is true, then we'd work with the body of the work. So the body means what are we actually repeating over and over. After that, we made sure that in the body, we also change the variable that we have initialized. Whether the change is positive or negative depends on the test. But remember, when the test condition is false, that's the time that this repetition structure will stop. That was the while loop that we did yesterday. Moving on to the activity that I left with y'all. The activity was to create a maths tutor that will allow the user to choose what operator to test and ask questions based on that operator. The program will end when minus 99 is entered as an answer. The operators to use for this problem will be addition, subtraction, and multiplication. And yes, this was very similar to the first maths tutor program that I gave y'all. And we're just going to look at that quickly. So I'm going to open up the maths tutor program. Drag it over. All right, so this was the maths tutor program. So you notice that everything else for the first step is the same as the first maths tutor game, except for instead of -1, we've got -99. We still got the score is 0, but this time instead of setting the count to 0, I set the count to -1. I'll get to that a little later on into this program, why I set it to -1. Now I randomly generated the two numbers that we're going to do addition and subtraction and multiplication. And then we ask the user to choose from which one they want. Finally, I got the user's choice. So we got if they choose 1, 2, or 3. And if they choose 1, 2, or 3, we do addition, multiplication, and subtraction. And next, I set the user's answer as 0. So I'm assuming that if they started this program, they definitely went to put answers. So I'm going to check, is that answer, is the user's answer that I default set to 0 at the start, not equal to -99? And if it's not equal to -99, we're going to continue into our while loop. And for the first time, it's going to go there automatically. And that's the point where I said, okay, now since I'm inside the loop, I'm going to increase count by 1. Now that I've increased count by 1, if you remember, it was -1. Now it's 0. So now it's going to ask the first question. So depending on what the user's choice, remember the user's choice was on the outside of the loop. So I got the user's choice. If the user's choice is 1, I'm going to ask them addition. So I got the addition. And of course, with the same one, this was the addition one that I had before. I just copied that and pasted it in, except for I added on this extra if statement because of addition. Now I copied and pasted the same thing 3 more times, and there we have it here. 3 more times I've copied in, well, 2 more times I pasted it in. Next, I changed the addition, all the addition ones to the subtraction, and all the subtraction after that to multiplication. And of course, I went with if the user's choice is 2, they're going to do subtraction. If the user's choice is 3, they're going to do multiplication. And it was the same question over and over, just with the score being updated to the score +1. So whatever they originally had, +1. Finally, at the end of asking them the question, we've got whatever number that we're generating for the next set. So for the next set of information, it'll then, because they put an answer already, it'll go to the top and it'll increase count by 1. So count now becomes 1. So it'll become 1 because remember the first time it was -1, then 0, then 1, and it's going to go 2, 3, and continuously upwards. So that the last number that we've entered will not be taken into consideration. That's why I started at -1. All right. So if I just quickly run this program to show you how it looks, the program would look as follows. Enter in -99 to stop the program and the following for the test. So what operator do you want to choose? And I choose operator number 2. Let's go with subtraction. There you go. It's asking you for the subtraction one. So 1 minus 12 is -11. It gives us that's correct. Then I'm going to give a incorrect answer. And it tells us the correct answer. I'm going to do one more. And then I'm going to finally put -99. Now you'll notice that it gave me 3 questions that I've answered actually. And the last question, I'm not answering it, but it's going to tell me I got it wrong. And it's going to tell me what the answer is, but it won't count it in my number of questions that I've actually answered. The reason is I've only answered 3 questions. The 4th one it takes as incorrect automatically. So there you go. It says, I'm sorry, the answer is 3, but what the actual answer was, oh, sorry, something got broken there. All right, let me just run it one more time. For some reason, I think I typed in the wrong place. All right, so 2, enter, okay, 0, 5, 3, -99. There you go. Your final score is 1 out of 3. The 4th answer it did not take, but it told you what the correct answer was. Right? So that was the maths tutor game or maths tutor, you can call it. Right, so that was the maths tutor, and that was the while loop activity. So I'm going to quickly close that. And let's stop right there and check a little activity that we can use with while loop before I start with functions. So let's make a little screensaver using loops. So something a little fun that you can do a part of just doing normal maths calculation with loops and so on. So let's open up a new program. File, new program. So I got my new screen open. And for those of you all that actually looked at the grade 8 work and went through it, you'd notice that in the help option, there's a turtle demo that the teacher showed you all. And in the turtle demo option, you've got a little example of different types of visual aspects you can program. Of course, there's the clock. If you start it, you've got the clock running. If you notice this little defs part over here, these are what we call functions, which we will start off today, but continue later on, right? And by the way, this is the actual correct time. So if you look at this, it's actually 3:10. So there you go, it's showing you the computer's time. 15. Right. Of course, there's other examples you can do there, but we're going to create our own one, a simple one using the looping structures that we've learned. Now I understand that I haven't actually shown you how to use the turtle functions, but it's okay. You can just follow along with me. Right. So the first thing I'm going to do is I'm going to save this program. So I'm going to save it as, I'm going to give it a name. So I'm going to call this all screen saver. Right. Now, the first thing I'm going to do is I'm going to import the turtle frame. So that little box that you saw before, that was what we call the turtle frame. So I'm going to import the turtle frame. So I'm going to import turtle. That's actually going to be doing most of our work for us. We'll be using the built-in functions there. Right, so it's import turtle. And now you notice that I didn't go from turtle import everything, because what I'm going to do here is later on, we're going to build onto this project. And when we build onto this project, we're going to have more import statements. And just to make sure that we don't get confused with all the import statements, we're going to specify a single import statement, right? So importing turtle at the start. Next, I'm going to create the screen size for this turtle function to work. So we're going to go right, screen is equal to the turtle, turtle dot screen. Now you notice that screen here is spelled with a capital S. Okay, so just not to confuse you, I'm just going to call this my screen. Right. So what's this going to do? It's going to import the screen into my screen so I can actually create that screen for what you saw before. So next thing I'm going to do is I'm going to set the size of the screen. So I'm going to go my screen dot screen size, and I'm going to give it a width and height. So I'm going to go, just for the time being, 300 by 300. Next, I'm going to give it a background color. So I'm going to go my screen dot bg color. BG color stands for background color. Of course, you can see color is spelled C-O-L-O-R. This is the American spelling of color. So I'm going to go background color, and I'm going to choose white in small letters. And finally, I'm going to say, okay, on the screen, I'm going to draw my object, which is going to be a ball. So I'm going to go my screen dot, before I can, right. So let's put a title first. Screen dot title. Screensaver. Right, so I've got a title for the frame. Just to show you what everything looks like here. So I'm going to just go to the end of this program and make sure that everything works. So I'm going to go my screen dot main loop. Now what this does is it just activates the turtle function. So if I go run module, this is what it created for me. It created a little frame. The frame is 300 by 300. Well, it's supposed to be. And this title of the screen was Screensaver. Next, I'm going to create the ball on the screen. So I'm going to go ball. Remember now, this is just going to be a variable. So it's going to be ball equal to turtle, T-U-R-T-L-E. And this turtle is going to be turtle. Later on, we get into what this actually is. It's just a class that we're importing, right? Then I'm going to go ball dot shape. And of course, a ball shape should be, yes, circle. Right. So I'm going to go circle. Next, I'm going to choose the ball color. Dot color. And let's go with red. Next, I'm going to say, right, the ball is on this, the ball should be on the screen. So let's just run it and see. Pull it over. There you go. I've got the screensaver with the ball on the screen. So now I can tell the ball to go anywhere on the screen and it should follow. So if I go to and say ball dot go to, and I give it a coordinate, like let's say for instance 0, 100. that ball now should move from where it is to that position. So there we go. And you can see the ball started off here and it went to the position that I've asked, so 0, 100. Now, the reason why there's a line here is because after we drew the ball in the center of the screen, and whenever you make a turtle screen, the object is automatically drawn in the center. So the ball was made in the center, then we set it to move, so it drew the line. So if I don't want to see the line there, all I have to do is tell the computer, before you can go to the position, make sure that the pen is up. So I'm going to go ball dot pen up. So now what this function here will do, it'll pick up the pen so I don't see that little line that's there. So I run it, and there you can see the ball is from where the center of the screen was here, it went up. Next, I'm just going to quickly say, give some coordinates there. So I'm going to say ball dot y coordinate equal to 2. This is just to make sure that I can change the position later on. And we've learned while loop so far, and we know that a while loop runs when a while loop is true. So I'm going to put while true. What this does is it makes this loop forever run. That means this loop will always run until I press that little close button or execute button, right? So when this loop is running forever, what do I want to do? I want to change the coordinates of that ball. So what I say is ball dot set y. So this is going to be setting my y coordinate. And because now I'm setting my y coordinate, I need to tell the computer what's the y coordinate. So tell the computer, all right, the y coordinate needs to be whatever the ball's current y coordinate. And how we get the ball's current y coordinate is by saying y core. And y core means y current, right? So we get the y current coordinates, and we're going to add whatever we changed the ball by. So there's the ball y coordinate there. So I'm going to copy it and paste it here. And let's see what that does. So here's my screen, here's the ball, and you can see the ball is going upwards. Of course, it went up and it left the screen. So the reason it went up and left the screen is because I have a positive 2 here, and what's happening is it's taking whatever the current coordinate of the ball is, and it's going upwards. So if I start at 0, 0, which is the center of the screen, here's the ball, and there you go, it's going up, and it left the screen. The reason it left the screen is because I'm telling the computer, you're going to continuously add 2 to whatever the number is. Of course, this is just making the animation slower, right? Next, I can go, okay, what if I don't want the ball to go past the screen? It must come back down. So I say, all right, if that ball, now what you should understand is this entire frame here works just like your X and Y coordinates on a Cartesian plane. So if this was my center, going up is positive for Y, going down is negative for Y. Going to the left is negative for X, and going right is positive for X. So I need to tell the computer, right, if you're going up, now you need to go down if it's too far up. So ball dot Y coordinate. So if the ball dot Y coordinate is greater than equal to 300, that means if it's going past the 300 mark on the top, then it needs to change direction. So I say, all right, if that's the case, we can change direction and go downwards. And how we change direction is taking the change of the Y and making it now negative. And we know that we can make a negative number positive or a positive number negative by just multiplying by -1. So I can say ball coordinate Y is equal to whatever the Y current value is times -1. and this will change. So if the y value was negative, it'll be positive. If the y value was positive, it'll be negative. So if I run this now, there we have the ball. It's going up, but this time as soon as it goes past there, it bounces and comes back downwards. Of course, when it goes downwards, it's gone past the bottom line. The reason it's gone past the bottom line is because we didn't check if it's less than minus 300. So we're gonna quickly copy this line and paste it. And now we say in the computer, right? If that value now is less than equal to 300, do the same thing, change the coordinates. So now if I run this module, I'll have a little bouncy ball. Wait, oh, sorry, it's still stuck. 1 second. All right. Okay, so for some reason it doesn't want to work now. Created y coordinates. There we go. There. Greater than 300, we're going to multiply. If it's less than 300, we're going to multiply again. Okay, I'm just going to copy over my last code that I had. I'm not sure what I changed over there, but here we have it. So we got the ball going up and the ball going downwards. But this time when it comes down, it bounces back up. Now we can do the same thing to the X and the Y axis by just changing the information that we have by simply saying, all right, we've got ball Y. So what if we want to change the X axis? We go with the ball in the X axis. And by the way, this 2 over here in front of the Y and the X just changes the speed. So if I put the speed there to 3, it just adds on the 3 to the speed. So it gets a little bit faster. Right. So I'm going to just copy and paste. So this would be on the next line. Ball dot set X. And just like on the top one, we'll go ball dot X coordinate plus ball dot X. Remember, this X is coming from here. The same thing will happen now, but just now this will run in a different direction. So if I just open this quickly, here you got the ball, and this time it's going sideways. And of course, it will bounce on the top, but when it comes to the side, it's going to go across. The reason it went across again, because we didn't tell the computer what must happen if it touches or go past that mark of the frame. So I'm just going to quickly type this out there. So this would be ball for the X, and it's exact same code. Just now it tweaked the numbers a little bit more so that it looks a bit better. So if we run this module now, we got a little bouncy ball. That would go to the bounce on the top, bounce on the right, come to the bottom, and bounce again. So I'm just going to quickly let it run to show you that it bounces on both the edges. Right, so we got a bouncy ball that's going there. Of course, you can speed this up by just increasing the numbers. That's here, that'll be the speed of it. There we have. Ball's going to go faster, but you can see that the image doesn't look very clear or animated properly compared to if you go 0, 1, or 2. Right, so you can use while loops for stuff like this. Now you can also make the ball change by using your X or Y, using your keyboard arrow keys. Sorry, my net slowed down there for some reason and got cut off. Right, so let's continue from this. So we've got the ball going X and Y. So that was a little something that you could have worked on and you can change later on how you want to use it, right? This program will also be in the folder. So if you want to download it and play around with it, you can. And you can make different shapes instead of a circle. You can go with others. Of course, you can check in the turtle help menu on what are the other shapes you can use. All right. So going back to today's work, since we took a little side tour, let's go back. And PowerPoint presentation. Right. Next, functions. What is a function? A function is a block of code that will only run when it is called. For example, if your parents call you, you'll go to them, right? So a function works similar to that. If it is called on, then only that code will work. If it's not called, that code will not work. So it's similar to the if and the while loop, that it has to have a condition, then the condition is it has to be called. The only difference is now this helps us make our code much more simple to use. For example, that maths tutor that I showed y'all with the addition, subtraction, and multiplication, it looks a bit complex and confusing for some because there's a lot of code in one section. But if we have to split that code up into smaller parts, it'll be much easier to understand. And that's what where functions help us with, right? So if we go on, we have three main types of functions in Python that we use, and that is the first one, a function that is called and will do work for us. That means it will just do work for us. And we've been using a function like that so far. And the function that we used so far was that is the print function. If you remember, the print function, you say print in brackets what you want to print, and it will automatically do that work for you. It's not going to give you an answer. It's not going to ask you anything. It's just going to print. So that print function is a type of function that just does work for us. Then we have the next function, which is a function that we can use to call our work, or so we can send data to, and that this data that we send to this function is what we refer to as a parameter. And there is a function that I haven't shown y'all, but we can use, that we can send information to a program and it'll do work for us, and that'll be it. Right? And we get back to that in a later lesson. The same thing with function 3, a function that is called and can return an answer to us. Now, this function will do work for us and it'll give us an answer. And a function that we have used so far like this was the input. When you say input and you put information in the brackets, you sent that information to someone else to do the work for you. And what did they do? They gave us back the answer that the person has entered in the keyboard. So that input is a type of function like that. And of course, I said we have three main types of functions, but we do have a function that is a combination of 2 and 3. So that means we can send information to a proceed, or in this case, a function that we want, and we can get a result. We'll get to that later on, okay? So don't stress if it doesn't make sense so much right now. When we actually do activities, it would make sense. All right. So the reasons why we use functions. We use functions to reduce duplication of code. You may say, right, but we did the same thing with the for loop and the while loop. We reduced duplication by using those loop instructions. And yes, that is correct. We used the loop instructions to reduce duplication, but now this further reduces duplication by allowing us to do the same thing in multiple programs. That means you can now access some other program to do work for you. For example, when we have imported the math when we imported the random module, we use the rand range. That rand range is a function that somebody else created, and they said, all right, I know that people might want to use it, so I'll just put it in the Python coding for you, and you can reuse it over and over. And since you use it over and over, you don't have to code that ever again. So you can make now later on a program just like that, where you program it once, and whenever you want to refer to it, you just import it and call it. And yes, you can do that. Right? Next, it makes complex problems simpler to solve. Complex problems, just like the tutor problem that we had, looks a lot complex, but if you break it up into its smaller groups, it's easier to understand. And if the smaller groups were, you're doing addition, so why not just code the addition? If you're doing subtraction, code the subtraction. If you're doing multiplication, code the multiplication. And after you code them, then use them, right? Improve clarity of the code. Since it's simpler to now solve, it's much more simpler to read, right? And finally, we can reuse the code. If it's reducing duplication, reuse code over and over in other programs, except for that one way you coded. And of course, information hiding. Information hiding is you don't want other people to see how you solved it. You just want them to use the code. Just like the rand range, you don't know how the person coded it, but we're using it because we know how to use it. So it's hiding that information on how to actually run that code. So we just know to use it. And so it hides information. Next, writing a function, right? So we're going to go with the syntax. Now, the most important word in this function is the word def. Def is short form for define. So we're going to define functions. And we're going to use the word def as a keyword to define a function. And how we do this is as follows. The first one I told you about was the function that will just do work for us. We run the definition as def function name. Function name means what is it you call in this function. Then we have the parentheses or round brackets and the and colon. Next, inside there, we have indentation and the body of the function. Body of the function means what must I do if this function here with this name is called, and I can have multiple lines over here. That will be done. Right, so that's the first function. The second function, we have def again. Remember, it's a keyword. Whenever we see def, it's for defining a function. After that, we give it a function name. And because we're giving a function name, now I can also put down arguments. Arguments are what values are you going to send to this function to use? What information must this work on the inside this body know in order to do the calculations? For example, when you are using the input box, you send in through a question. So the person knows that inside here, they need to get the question, right? And arguments is what is the value that is being passed between the programs or functions. So from one program to another program, you can send information. And if you look at other work or other books or textbooks, you'll see that they'd either refer to this as arguments or parameters, right? So arguments and parameters, basically the same thing. Next is the third type. The third type is you defining a function name. Again, same thing as the top ones, but this time inside the body, after you do all your work, you have a return statement. This return statement has an argument. That means now you also going to send back an answer. And if you remember, that's what the input box does for you. It gives you the answer that the user, that the person that's using your program has inputted. But the difference now with the input box and these two functions, it's a combination of these two functions, because in an input box, you're going to send an argument and you're going to receive an answer. So an input box is a combination of these two functions, Right. So these two functions we'll learn in the next lesson. So let's start with the first one. Right. And when writing a function, there's a few set of rules or instructions you need to know. Firstly, a function begins with the keyword def, followed by the function name and parentheses. Parentheses means those round brackets. So you must have def followed by the function name and parentheses. The name of the name of the function must not have any spaces. So that name that you have in a function, let me just go one back. This name that you have here must not have a space. So if you want to have something separating it, can put an underscore, that's perfectly acceptable, right? But no spaces. The case the name is written in is important. That means if I write something with fun as in capital letters and fun as in small letters, those will refer to as two different functions. But remember again, Python is case sensitive. That means it will refer to them as different variables. When passing parameters or arguments, they must be placed within the bracket. So they must be placed inside the parentheses. So if you want to send information, it must be inside those parentheses. You can only call a function up if it is created before you call it. I know that sentence doesn't make much sense for some of y'all, but put it this way. Your parents can call you because you were born. If you weren't born, they can't call you. The same thing with a function. A function can only be called after you write it out. So you cannot write, you want to call the function and then write the function out. Because remember, Python reads from top down. So if it's reading from top down, it's going to read all the lines above, then it's going to come to the work that you want. Right. So let's look at the first function. So we got def function name and the body of the function. So if we look at an example, and we always start with the hello example. So we're going to go with def hello function or hello underscore function, parentheses, colon, and we go print hello from inside the function. So I'm going to quickly open up the Delphi program. Here we have the Delphi program. And you can see I just added on slightly more here. So this is what it looked like. I'm just going to cut off this part. Right, so here's my function. There from top down, Delphi will read. So Delphi read all the lines from the top down, but because this is just a definition of a function, it will not run this code. So all definitions it'll read, but the only time it'll run those definitions is if you call it up. And how we call up a function is by its name. That's why it's so important that you know what you called it. So you can see here, I called this function, I defined it as hello underscore function, round brackets. So when I come to line 5 here, I called it up by saying hello underscore function, round brackets. So if I run this module now, it'll give me the answer, hello from inside the function. And just to show you that just to show you that Python will not run functions unless it's called, I put in this line here, line 4. So if we just look at it, Python should have went line 1, line 2, line 3 is blank, then line 4, then line 5. But again, now you should understand that line 1, there's a definition. So this line 2, which is indented, belongs to this definition. So the only time line 2 will run is if line 1's definition is called. But if we look at this, the only time it's called is at line 5. So it's going to print, hello, welcome to the world of functions. Then it's going to call the function. And finally, when it calls the function, it'll print from hello from inside the function. So what will our display be? Our display will be firstly, hello, welcome to the world of functions, then hello from inside the function. Let's run it. There you go. So it ran line 4 when it printed out that line. Then when it came to line 5, Python said, I'm calling on my function, hello function. So it went back to the top and it went and found hello function. The hello function is here, and it did the work on the inside, the body of the work. So it printed out the inside. That's why hello from inside the function comes second. Right. So that's what we call, or that's what we talk about by you cannot call a function before it's created. So there's the function created here, then I'm calling it. What happens if you call up a function before you can create it? In other words, what happens if I put hello function and then I define it? The computer will simply break. There you go. And the why it broke, it says hello function is not defined. You may say, but there, I defined it in line 3. But you defined it in line 3, but you called it in line 1. You called it before it was created for you, right? So make sure that when you call up functions, it's always created first, right? So that's our first function. Now you may say, what's the use learning this if you can just use loops and so on? Well, part of making life or code easier to write, it's meant for when you want to practical use of making applications like games, for example, like the little ball that's bouncing up and down. Now imagine if I had to control that ball with an arrow key. Every time I press the up arrow, the ball must go up. Every time I press down, it must go down, left and right. Now, if you have to code a while loop to run forever on that, now you're going to keep on checking the key pressed. And that will keep on making the program get slower because it's going to get more code. But if you use it in functions, the function only runs when that key is pressed. So when technically Python won't know or won't read that line unless it's called. So all the extra code won't be read. Okay, let's go with another little problem. Next, what if I wanted to display the words hello in characters? Now, this is going back to our first day of coding on how would you actually print out information. And if you don't understand what I'm talking about, I'm talking about this. Hold on, let me just open up the program. Okay, so what if I wanted to display information like this? Hello. All in hash signs. You'd simply say that's easy to do. All you have to do is, yes, write out a whole bunch of print statements and make that design. And you'd print it out like that. But then I come back to you and say, okay, I don't want hash signs. I want star signs. You'll probably say, yeah, you change the hash signs to star. And then while you're doing it, you come 3/4 of the way down. That means you're just done with the L and tell you, sorry, I don't want stars. I want the at symbol. You'll get frustrated and tell me, go do it myself. Right. But as coders, we must be prepared for that. And how we prepare for that is instead of putting hash signs down, we actually can put down variables. And when we put down variables, it helps us put down our code easier. So I'm just going to open that up. Okay, for some reason, it's not in this folder. And so I'm going to just get back to this. There we have, I'm going to replace my code that's here. Right, so I'm going to go File, New, quickly create it. Right, so there we have it. Copy. I'm not showing you the final outcome. I'm just going to paste what it should look like, right? Okay, so there's the HELL and the O. Now, if you notice, I put the L twice. Oh, sorry, I put the E twice. Copy, paste. No, went the wrong way. Right, I just need to make sure that everything goes back to the way it's supposed to. Right, so let's just make that there. So what I did in this program was I said, okay, instead of putting the star signs, let's put L to represent the letter that they're going to put or the character that they're going to put. And at the start of this, all we have to do is get what the character that they want to put in is. So I go at the start and I say, all right, L is equal to the input enter in the character to use. Because now if I press F5, it'll ask me to save. Python lesson 7. Right, it's a character with letter. So it'll ask me, what's the character I want to use? I want to use an @ symbol, and it'll design the hello with the @ symbol. Now, if you notice, the L is being done twice. So yes, you can tell me you can put it inside a loop, and I'll tell you that is correct. You can put the loop and you can say run the loop twice for the L. But since we're doing functions, there must be another way, and there is. The alternate way is we can now copy this little pieces of code into a function, because at the moment it looks a little bit confusing on what this entire thing is doing. Because if I just give you something like this here, you'll say, unless you run it, it's a print statement, but it's hard to decipher what it's doing. So we'd run a function, and we'll run a function for each of those letters. And how that function for each of those letters would look is as follows. Right. So I'll say I'm defining function h, and I'm going to send through L. So if you notice, that's the second option of a function where you can send through a parameter, right? And there we go. I put down the print statement with the extra line. So each one has the print statement with the lines. And at the bottom, I've got in the character to use. So now it makes life easier because now you can see what each of those pieces of code is doing. So if you didn't know what this was here, you can see you're defining H. So it must be the letter H. And of course, I can go down here to my main program. That's going to run first, because remember, functions don't run until it is called. And for those of you who have the question, can I go and put a function after I write my program? So can I do something like this? The answer is yes, you can. The only difference now is, again, you must make sure that you call it only after it's created. That's the rule that you must follow, right? So let me put it back there. All right, so if I run this program, there we go. We have hello with the stars. But if you notice, there's it here, hello. So now I got it there. I can simply go back to the previous program, take that input box, put it in here. There's a lot of copy and pasting. Remember, it's coding. You're allowed to copy and paste. All right, so, and of course, I can now change the stars because I don't want to send through the stars. I want to send through the letters. So I send through L. Now if I run it, it'll ask me what letter to use, and I can choose any letter I want or any character I want. Line string not come. Oh, the reason it broke is because the mod symbol somewhere along the line with the L, it made another separate character, and we'll get into that type of problem later. All right. String object not come. Okay. So for certain characters, it doesn't want to work for the L symbol, but it'll work for the HE. And that means there's something wrong with the plus some sign there. That's fine. That can just be fixed later on. Okay. So that's the functions and definitions and how to just make definitions for you. Now, you don't only have to do it with little outputs like this. You can actually make a program to do the work for you. For example, the addition, subtraction, and multiplication program that we did. We can actually convert that into a function program by simply looking at what we had and copying out the bits that was complicated and did most of the work for us. So I'm just going to go back to that program. It seems that it's missing again. There we have it. All right, so you notice that this part of the work did the addition for us, so we can actually create a definition for each one. We'll create it, well, I'll leave you to create the definition for each one as an activity, but I'll show you how you can start it off. So I'm going to go new file. Oh, I already got the new file, so I'm going to file save. I'm going to just keep this as a little simple maths program. So maths lesson 7. All right. So if I want to do addition, I would go define, and I'm going to go addition. Well, I'm just going to short form add. Now you don't have to have underscore function or function underscore. You can just have a name. Just make sure that when you put in a name, it's not one of the special words that Python uses, like sum. Sum is a special word that Python uses, so don't create that. How you know if it's a special word as well is because when you type it out, it changes color on a normal place. Right. So that's why you don't see me using sum, because sum, what it does is it's a function that takes in numbers and adds it together for you. You may say, but that sounds easier than putting it yourself. Remember, we learning how to code, and we coding from first principles. That means from the start. So we go add. And what do I want to add? I want to add 2 numbers. So I'll say number 1 and number 2. Again, you don't have to worry too much about this. We'll get to that in tomorrow's lesson. All right. just going to show you what is in store for tomorrow. So we got number, define add, and I can simply say my answer is equal to number 1 plus number 2. And I can say print answer. Or better yet, let's use the print version that I showed you all yesterday, where you don't have to use plus signs, but you can just put in commas instead of it. So I'm going to say the sum of, comma, number 1, comma, and, comma, number 2, comma, is answer. Remember, the semicolon is just the replacement for the plus sign. And because we got comma now, we don't have to say that, or we don't have to tell the computer what's string and what's integer. It'll automatically take everything as string. And finally, I can go number 1 is equal to input, enter in number 1. Right, this needs to be inside the quotes. Now this, on the other hand, needs to be converted to an integer, because when I send it through, I'm adding, and whenever we add, we can only add numbers. I'm just going to copy and paste. And change. Then finally, I'll call up the definition that I made, and which is called add. And in add, I'm going to send through number 1, comma, number 2. I'll explain this all tomorrow, so don't stress. Run it. There we go. Enter number 1. Number 1 is 2. The 2 is 9. That gives me the sum of 2 and 9 is 11. So that is the functions and definitions and how to create the first set. Again, don't stress too much about the second type where we actually get input, because I will explain it to y'all tomorrow. For today's activity for you to do, is the following. I started a program. If I can just open it. That's not there. Hold on 1 second. I'm so sorry. Oh, low. Oh, I think it's, yes, it's this one. Right. It's called letters. And so far, I put in the definition for A, B, and C. And of course, you can see I've got the position. So if we quickly run this, you can see what the output looks like. So it asks me what letter I want to use. So if I use the @ symbol, it shows me A, B, and C in the @ symbol. Your activity is just to copy and paste this around and see if you can at least go to the letter Z. So you can have all the symbols, and then who knows, maybe you can actually make words with it by simply changing it. So remember, as long as you put in your call after that, that's the words that's going to display on your screen. Let's use $. There we go. This changes. So depends on what you call And as you can see, I got A, B, and C, but I didn't call C. That means this entire part of the code, yet it is read into Python, won't be executed because this definition is not read. Right. I hope you all had a good lesson today. And is there any questions before we go off for today? All right, so if there's no questions, the upload will be this as soon as the files will be in the folder as soon as I cut the lesson over, because I hadn't had a chance to upload it as yet. So I'll see you then. See you tomorrow when we go on to the next 2 steps of functions. Have a good day.